A 10-gram bullet is fired into and embeds itself in a 2-kilogram block attached to a spring with a force constant of 19.6 newtons per meters, and whose mass is negligible. How far is the spring compressed if the bullet has a speed of 300 meters per second just before it strikes the block, and the block slides on a frictionless surface? So what I did was I drew a diagram right here, and I listed the given values, and that gun looks horrible. But anyways, so there's two masses that we need to take into consideration, and oh wait, this is not final velocity. That'll get confusing. This is an initial velocity according to the system, which I'll explain in a second. So listed all the values, and then in the hint it said you must use the conservation of momentum in this problem. Why? So this is an inelastic collision, which I realized, because the bullet is transferring kinetic energy to the mass, and that not all the energy is going to be transferred. If you think about it, some of it's going to be like go to heat or some other source. So I used the conservation of momentum, and I plugged in the values, and so the initial velocity of the block is 0. So here we go. I isolated the final velocity of both of the masses, because the bullet will be inside the block afterwards, and I got approximately 1.49 meters per second. So then we can use our knowledge from what we learned in this chapter, and if we think about the elastic potential energy, or the spring potential energy, so the potential energy in the spring will be equal to the kinetic energy that's from the inelastic collision. So I did kinetic energy equals the spring potential energy, and now we have a velocity to work with. That was the whole problem I had. I didn't have the velocity, and so you can just isolate x because it's asking for the displacement of the system of the two masses, and you just plug in the values. Everything else is given except for the velocity, and you get approximately 0.478 meters.